Hey class, Mr. Houston here. Today we're going to be starting chapter 12, which is all about probability. And today we're just going to dip our feet into it with chapter 12, lesson 1, finding probability and odds. Okay, so the first thing we're going to talk about is finding a sample space. When it comes to probability, you are going to need to know the total number of outcomes that you are going to have. And so one way of doing that is using what we like to call a sample space. So how we create a sample space is, first we're going to say that you are flipping a coin and you are rolling a number cube. How many possible outcomes are there? And we're going to list all the possible outcomes. So when you flip a coin, you have two options. You have heads and you have tails. Then you roll a number cube. In case you don't know what a number cube is, it's like a dice. So when you roll it, you have how many options? You have 6. So we're going to try and fit all those here. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So we would kind of draw little arrows out to all of them. And then if we wanted to, we could list out all the options we could have. So we could have a heads and a 1, heads and a 2, heads and a 3, heads 4, heads 5, and heads 6. And then we'd have a tails 1, tails 2, 3, 4, 5, and 6. So if we look at these, if we count all of our outcomes here, we'd have 6 when we flip a heads, and we'd have 6 when we flip a tails. So we would have 12 total outcomes. Another way to come up with that, and we'll talk about that more in later lessons, is how many total outcomes are there on a coin? There's 2. How many total outcomes are there on a number cube? There are 6. 2 times 6 equals 12. So that's another way to come up with the total number of outcomes. So that's a sample space. Again, that's just to figure out how many possible outcomes we have when we are looking at the probability or the odds of something happening. Okay, so probability usually comes out as a fraction or a decimal, and based upon that decimal you can tell how likely something is to happen. If it's at 0, it's impossible, never going to happen. 0.25, there's a chance, but it's highly unlikely that it's going to happen. 0.5, that's like a 50-50 chance. 0.75, now we're getting closer to our outcomes are more favorable for us. And then if you happen to get a probability of 1, then it is certain that it is going to happen. 2 types of probability we're going to talk about today. The first one is known as theoretical probability, and that's all based about the theory of it. Okay, there's no necessarily data behind it. It's just the theory behind everything. And how we find that is the number of favorable outcomes over the total number of outcomes. So what that would look like, if we're looking at example number 2, you and your friends design t-shirts with silk screen emblems. You are selling the t-shirts to raise money. Table below shows the number of t-shirts you have in each design. A student chooses a shirt at random. What is the probability that a student chooses a red t-shirt? Okay, so how we are going to write this, because there's shorthand for everything in math, is we say the probability of a red t-shirt. Turns out that probability is a long word, and we don't like to write that out. So we just put P of red t-shirt. So that would be the number of red shirts over the total number of shirts. So we come up here, we want to look. Doesn't say anything about any emblems, it just says a red t-shirt. So the total number of red t-shirts is 12. Now the total number of t-shirts are going to be the 12 red t-shirts plus the green t-shirts, which are 18. So 12 and 18 will make 30. So then we'll simplify that fraction down. 6 goes into both of them, and we'll get 2 over 5. And we'll also give that as a decimal, which will be 0.4. So this is, if we look at our scale up here, 0.4 falls in between the unlikely and equally likely to happen or not. So we're kind of in the middle almost. So the odds would say that you're probably not going to pick a red t-shirt, but you do have theoretically, you have a 2 in 5 chance of picking a red t-shirt out. All right, so again, theoretical is the number of favorable outcomes over the total number of outcomes. We'll get that as a fraction, simplified, and then we put it as a decimal. All right. The other type of probability is known as experimental probability, and this is when you've actually done the experiments, okay? Because it's the number of times you were successful over the total number of trials. So we're going to look at example 3 here in a standardized test practice. Each section of the spinner shown has the same area. The spinner was spun 20 times. That's important. That is our number of trials from up top here. Okay? The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical probability? So first off, let's talk about what theoretical probability is. So the theoretical probability is it's what you want to, the number of favorable outcomes over the total number of outcomes. And the theoretical probability for each of these is the same. And that is you have a 1 in 4 chance. Let me back up here and put theoretical. So in theory, you have a 1 in 4 chance of picking any of those colors, okay? Because there's only one of the colors and there's 4 possible outcomes. Now the experimental probability, again, we have to put the number of successes over the total number of trials. So we want to look in here at our chart and try to figure out what number of successes. We already know our number of trials. It's 20. What number of successes will give us a 1 in 4 chance? So if I look here, okay, 5 over 20. If I take 5 over 20, 5 goes into 24 times. We get a 1 over 4. Oh, lucky guess on the first time. The probability of red in this case would be 5 out of 20, which is 1 over 4, which is also its theoretical probability. So our answer here is red. Again, experimental probability. How many times did it happen over the total number of times you attempted it? Okay, so that's the little difference between experimental and theoretical. And finally, example number 4 asks us to look at the spinner pair. It says in example 3, find the odds against stopping on green. When we're finding odds, when it's the odds for something, it is going to be the number of favorable outcomes over the number of unfavorable outcomes. And so therefore the odds against, let's see if I can, odds against is exactly the opposite. You're going to have unfavorable over favorable. So we want to know the odds against stopping on green. So the odds of not green. So how many unfavorable outcomes do we have? So up there in that picture we have 3 that are not green. And we only have 1 that is green. So the odds would be 3 over 1, 3 colon 1, or a lot of times you'll hear people say the odds are 3 to 1. Okay, so that's a little rundown of odds, experimental probability, and theoretical probability. Again, this whole chapter is based on probability, so hopefully this is a good introduction to it. If you have any questions, bring them with you to class, and we will see you then.